So writing each polynomial in standard form, I'm going to go ahead and go through these examples. Make sure we do our largest exponent, 9x squared plus 3x plus 5. Now I'm in standard form. This next one, my largest exponent is x to the 4th. Notice I have like terms here of negative 6x squared and 10x squared. So I'm going to go ahead and combine those, and 10 minus 6 is a positive 4x squared. I don't have an x cubed, so I don't have to put one. I could put 0x cubed, but we don't need that. My next one would be a positive 4x, and then a negative 12. So now I am in standard form because I go from 4 to 2 to 1 to 0. All right, let's describe the end behavior of the functions below. So again, leading degree is odd, and my a is positive. So you guys determine what's the, how's it going to go. If my leading degree is odd, excuse me, my greatest degree, leading degree is odd, and my a is positive, then I'm going to go down and up. That's all you have to say. Okay, so that means my graph would look something like this, maybe. All right, this next one, leading degree again, odd, and a is positive. So this one's also going to go down and up. But wait, what did I miss on this one? I automatically assumed that my leading degree was the first one listed, but look right here. I have a larger exponent. This one is not in standard form. Very common mistake that I know students will make. So let's go ahead and rearrange this. 2x to the 4th plus 8x cubed minus 8x squared plus 2. Now my leading degree is even, and my a is negative. So instead of having what we thought we had, we now have a behavior that would go down and down. So the end behavior would be down and down. And it would look something like this, most likely, just down and down. Okay? So there's your two examples so far in this section. Let's go ahead and do example 3. What is the graph of each cubic function? Describe the graph including end behavior, turning points, and increasing, decreasing intervals. So when we do this, you guys, the easiest way is going to be just to make a table. Excuse me, I'm going to say -2, -1, 0, 1, 2. Make a chart. You guys, I know you don't really like these, but we're going to do this. So we're going to say -2 cubed. We're going to put this -2 in right here. -2 cubed is -8. Just I want you to see what I'm doing. I'm substituting in. And then 1/2, sorry, not 1/8, thinking ahead there, 1/2 of -8 is -4. Okay? -1 cubed is just -1, and 1/2 of -1 is -1/2. Okay? Put 0 in, I get 0. 1/2 of 0 is 0. 1 cubed is 1, and then half of 1 is 1/2. And then 2 cubed is 8, and half of 8 is +4. So kind of there's my graph. Let's look at it. If we graph it, I'm going to erase this so we can graph it. My graph is really small. I'll do the best I can. So -2, -4 would be right here. My pencil's a little off. -1, -1/2 would be, you know what, let's go ahead and make this counting by 1/2 instead. So if I say -2, that would be here. It's like each line is now 1/2. So -2, 1, 2, 3, 4. My scale is now 1/2. Makes it a little bit better. -1, 1/2 would be right there. 0, 0, right here. +1, 1/2. And then 2, 1, 2, 3, 4. Okay. Okay. Notice, let's talk about the end behavior. My end behavior is down and up, and that makes sense because I have a leading degree of that's odd with a positive a, so down and up. Turning points. I don't really have any turning points because I'm not really changing direction. My graph is steadily increasing. As x increases, y is steadily increasing. And you can see that right here. Y is steadily increasing. So that's what we're going to talk about, increasing and decreasing intervals. I don't really have any intervals. It's just steadily increasing. Turning points generally create that. Now, I want you to understand that y is increasing. So even though like right here, my behavior is down, technically my y values though are increasing. As x increases, y is increasing. So my turning points will create some different increasing and decreasing intervals. So let's go ahead and do this next one. Let's go ahead and make it, again, a t-chart, make a chart. Okay, and we're going to use the same values. May not be able to do this one in my head so easily. So over here, I'm going to do 3 times negative 2 minus negative 2 cubed. Okay? So 3 times negative 2 is negative 6 minus, well, negative 2 cubed is a negative 8. Okay, remember, don't eliminate minus signs until you have actually looked. So negative 6 minus a negative 8 becomes negative 6 plus 8, which equals a positive 2. So when x is negative 2, y is positive 2. All right, let's do that again with a 1. So now we have 3 times negative 1 minus negative 1 cubed. You can put it in the calculator like this. As long as you put the parentheses in, you will be fine. Minus a negative 1 parentheses cubed. Okay, 3 times negative 1 is negative 3 minus a negative 1 becomes negative 3 plus 1, which equals negative 2. Okay? Funny enough, when we put 0 in both for x's, we're going to have 0. I just know 3 times 0 is 0 and 0 cubed is 0, so I'm not going to solve that one. That one's kind of nice. It's always where our y-intercept. We don't have a constant, so now we're going to do 3 times 1 minus 1 cubed. And 3 times 1 is 3, minus 1 is just 2. Okay, and when we put 2 in, we're going to do 3 times 2 minus 2 cubed, which is 6 minus 8, which is negative 2. Interesting how this graph is going to look, I think. So let's go ahead and graph this, and I'm not going to count by halves this time. So negative 2, positive 2 would be right here. Negative 1, negative 2 would be here. Okay, 0, 0, 1, 2, and then 2, negative 2. Okay, so my graph is going to do like this. Okay, so if we look at it, here is my leading degree. There's my leading term. So my leading degree is odd, and my A is negative. So I should be going up, down. So my end behavior is up and down. This one's going up, this side's going down. My turning points would be like right here. You guys can see my turning points. It's hard to see where I went through. My turning points are at negative 2, negative 1, negative 2. I'm trying to use my graph instead of use my table. So my turning point is at negative 1, negative 2, and then I have another turning point at 1, 2. Those are my turning points. And then my intervals. Right here as x, let me color the different color here. Right here, as x is increasing, my y is decreasing. So I have a decreasing interval from negative infinity to negative 1. And then from between negative 2 and positive 2, I have an increasing interval. Okay, and then from positive 2 to positive infinity, I have a decreasing interval. So that's kind of what the intervals are about, just showing what my y values are doing as my x changes, okay? What my y values are doing. So my x is always increasing, but we're looking at what the y values. We're looking at what the output is doing as the x is increasing. So for a while, y is decreasing. Then between my two turning points, it's increasing, and then my y is decreasing again. Okay? All right, last example for this lesson. Sorry this is so long. All right, we're going to talk about the degree of the polynomial function that generates the data shown below. All we're going to do here is we're going to look at the differences between our y values. So we're going to find the differences and we're going to look for patterns until we get to a constant pattern between differences. So from -1 to -7, that is a decrease of 6. And then from -7 to -3, that's an increase of 4. And then from -3 to 5, wow, that's an increase of 8. From 5 to 11 is an increase of 6. And then from 11 to 9 is a decrease of 2. And then from 9 to -7, wow, that is a decrease of, well, 9 there plus 7, that would be a decrease of 16. Well, there's obviously no pattern going on here. So now, if there were a pattern going on right here, this would be a linear function because that's my first set of differences. Okay, so now I'm going to do my second set of differences. So from -6 to +4, I am increasing. From -6, I'm increasing by 10. And then from 4 to 8, I'm increasing by 4. And then from 8 to 6, I'm decreasing by 2. And then from 6 to -2, I'm decreasing by 8. And then from -2 to -16, I am decreasing by 14. Again, no patterns. This would be a linear if we found a pattern here. If we found a pattern here, this would be a quadratic. In the second set of differences, that means that my degree would be a 2. I don't have a pattern there, so I'm going to continue on and look for another pattern. I'm going to do another set of differences here. So from 10 to 4, that is a decrease of 6. From 4 to 2, or from 4 to -2, that's a decrease of 6. From -2 to -8, that's a decrease of 6. And from -8 to -14, that's a decrease of 6. Bingo, we have found a pattern. We have found a constant difference. We found it in the third level. So this is a cubic function. So my greatest degree, the degree would be 3. Degree equals 3, which means it's a cubic function. So this data set right here is representing a cubic function.